NAND logical gate. NAND or not AND is a basic logic function that performs the logical AND operation and inverts the results. The inputs of a NAND gate can be connected to other NAND gates to create complex logical operations. Explain that the output of a NAND gate will be 1 only when both inputs are 0. We will consider a logic circuit with 2 inputs and 1 output. Right-click to change the designation of the circuit. Expand circuit. Then add the corresponding inputs and output that will allow accessing the created outputs in the circuit. Also add current and ground outputs to ensure circuit operation. Right-click to transition to a subcircuit and configure a NAND gate. We need 4 field effect transistors based on CMOS logic. Let's chart the scheme with a parallel arrangement of PMOS transistors taken from the library. Let's change their orientation. Then we will sequentially place NMOS transistors. We will make connections between the drain terminals of the PMOS transistors. From the junction area, we will draw a line downward and connect it to the source terminal of the first NMOS transistor. Next, we will connect the source terminal of this transistor to the drain terminal of the second NMOS transistor. It's time to place the inputs and output. Give them names. Connect the output to the junction of the drain terminals of the PMOS transistors. And connect the gate terminals of the NMOS transistors to the inputs. Connect the gate terminals of the PMOS transistors to the input lines accordingly. Don't forget to place an input to ensure the circuit's operation. Connect it to the source terminals of the 2 PMOS transistors. Also place the ground. Connect it to the drain terminal of the second NMOS transistor. Save the circuit. Now that all the necessary outputs and inputs are created, we can proceed to set them according to their positions in the circuit. Create a new circuit to test the logic scheme. Transfer the circuit from the Components menu and position it. Give the circuit a name. To maintain a constant current in the circuit, use a DC voltage. Place the ground. Use a rectangular voltage source as the input source. Next, place the ground. Connect the ground of all components to it and add a common ground. Now add an output. Modify the data of the voltage sources accordingly. Assign names to the input and output lines. After these steps, we should understand the pattern of output change in the logic circuit over a specific period of time. We need to perform a time simulation. Add the transient simulation component from the component list and adjust the component values as follows. Save the circuit. Make sure that ngSpice simulation is selected by default. Now let's go to the Document Settings section and uncheck Open Data Display after simulation. Start simulation. We can see the simulation run without errors and completed successfully. Now let's add a truth table to display the input and output values. Expand the table to view the results of our simulation. Also, add a Cartesian table to visualize the changing pattern of the NAND circuit more accurately. We can clearly see that at the inputs, when there is voltage at the output, we get 0, and when there is no voltage at the inputs, we get 5 at the output.